Good afternoon, everyone, and welcome to the lecture. This is lecture number 4 in electrostatics. We are dealing with electric field, and I think in the last class we had seen the properties of electric lines of force. We were dealing with the properties of electric lines of force. So these are imaginary lines drawn in such a way that if you draw tangent at any point, it gives us the direction of electric field. We remember this? We had
Yes,
seen
sir.
the properties that they are always drawn away from a positive charge. They are imaginary. They never can cut cross or each other. Cut cross each other. They are never in closed loops. They are always in open loops. They start from a positive charge and they end on a negative charge. We remember this.
Yes, sir.
Then, if you draw tangent at any point, that will give us the direction of electric field at that point. Yes or no?
Yes,
So,
sir.
if I just show you some snapshot of electric field line drawn. See, this is the electric field due to a positive charge. As you can see, electric field lines are all going away. Do we see this?
Yes, sir.
If you see the snapshot of an electric field of a negative charge, they are all coming towards the negative charge. Yes or no?
Yes, sir.
These are the electric field lines between between a positive and a negative charge. Between two positive charges. So they are all going away. I hope everyone can see this. You can also draw this because I've seen these questions come in exam. Not for a single charge they don't ask, but for multiple charge they ask these question. How are the electric field lines? Or they will draw the electric field lines and then ask you what type of charges are there. So this is how the electric field lines are drawn. Okay, then we will write their properties once again. We'll complete all their properties. Okay, I'll give you 1 minute to draw it. Completed, everyone?
1 minute, sir. Done, sir.
Boys, done? Yes or no?
Yes.
Okay. So we are basically looking at the properties of electric field lines. We'll continue these properties. So we have seen 2 or 3 properties up till now. Let me take you back to those properties. Electric field lines are imaginary. They never cut cross each other. They are not in closed loops. They start from a positive charge, end on a negative charge. Point number 4, tangent to electric field will give us the direction of electric field. Yes or no? Everyone understands this?
Yes,
Everyone
sir.
understands this? Okay. Then the next is electric field lines are always perpendicular to a conducting surface. If there is a conducting surface, electric field lines are always perpendicular. Electric field lines are always perpendicular to a conducting surface. So whenever you have a conductor or a conducting surface, electric field lines are always perpendicular to it. See, for example, here, this is a conducting surface. This is a conducting surface and this is a negative conductor. So what do you see here? Electric field lines, they enter the conductor perpendicularly. Here, as you can see, there is a positive conductor. The electric field lines are coming out in a perpendicular direction. Here, the electric field lines are going in perpendicular direction. Remember, inside a conductor, there is no electric field and therefore there is no electric field line. Electric field lines do not exist inside a conductor. Do we understand this? Yes or no? No, yes.
Yes, sir.
Electric field lines cannot exist inside a conductor. So inside a conductor, there will not be any electric field and hence there will not be any electric field lines. So electric field will either terminate on a conductor or it will start from a conductor. Whether it terminates or it starts from a conductor, it will always be normal. So I'm saying the same thing in different ways. Do we understand this?
Yes, sir.
All these points are reflecting the same thing. Yes or no? No, yes.
Yes, sir.
Okay. Have you noted it down, everyone?
Yes, sir.
Now, the number of electric field lines. What can you say about the number of electric field lines? Now, electric field lines, it comes out or terminates on a conductor. If the number of electric field lines are more, the magnitude of charge is more. If the number of electric field lines are less, the charge is less. So from a big charge, large number of field lines will come out. From a small charge, small number of field lines will come out. We will understand this in the next topic, which is known as electric flux. That is known as electric flux. So if the charge is more, flux will be more lines will come out. Do we understand this?
Yes, sir.
Telling you the same thing in different ways with the help of a diagram. I think I have already shown that electric field lines never form closed loops. They are always in open loop. Why do we say they are in open loops? Because they start from a positive charge and they end on a negative charge. Whereas if you talk about magnetic field lines are in closed loop. They don't have a starting point and they don't have a end point. You can see this. This is a magnetic field line. It is in a continuous loop. So we understand this. It's in a loop. But electric field lines, they are not in a loop. They start from one point and end on the other point. They start from a positive charge and end on a negative charge. Do we see this? That is what I mean by open loop and closed loop. Do we understand this?
Yes, sir.
Have you noted it down, everyone?
Yes, sir.
Then comes the next point. The number of field lines crossing a surface is directly proportional to the electric field intensity if the electric field lines are very close, very dense. You just have to understand, if the field lines are closely spaced, the electric field will be more, and when they are widely spread, the intensity would be less. Do we understand this?
Yes, sir.
That is what it is meant by the electric field intensity. The number of electric field lines give us the electric field intensity. The number of field lines are more, if the density is more, then the electric field is more. If the number of field lines are less, intensity would be less. Do we understand this?
Yes, sir.
Now we come to uniform and non-uniform magnetic electric field. Remember, electric field is a vector. So for electric field to be uniform, the magnitude should be same and direction must be same. If you see in figure number A, electric field lines are equally spaced. That means the magnitude is same and they are parallel. That means A will represent uniform electric field. Do we understand this?
Yes, sir.
In number B, we see that they are equally spaced, but the direction is different. That means the magnitude is same, but the direction is different. Do we understand this?
Yes, sir.
In C, they are not equally placed. That means the magnitude is different and the direction is different as well. Do we understand this?
Yes, sir.
Note this down. Have you noted it down?
So wait a minute, sir.
Okay.
Done, sir.
Okay. Then comes the next point. Electric field lines also give us an indication of equipotential surface. Now, we have not seen equipotential surface till now, but we just write this point. When we come to equipotential surface, then we will understand. In fact, this electric field E vector is always perpendicular to your equipotential surface. When we understand this equipotential surface, then we will understand it. Right now, you can just write electric field lines are perpendicular to an equipotential surface. We will understand equipotential surface. We will understand potential. Don't worry. Just now write it. Then you can revisit this. And also the last point where we say that electric field lines always flow probably is not the right word, are always directed. Electric field lines are always directed from higher potential to lower potential. Electric field line will always move from a point of high potential to a point of low potential. This is same as saying a body will always go from a point of higher potential energy to a point of lower potential energy. It goes, yes or no? This is a
Yes,
pen. If
sir.
I drop it, it will go higher gravitational potential to lower gravitational potential. Similarly, we have got electrostatic potential or electrostatic potential energy. Electric field lines will always move from a point of higher electrostatic potential to a point of lower electrostatic potential. Do we understand this, or this is gone above as saying bye bye?
Understood, sir.
Okay, you have 2 minutes to note it down.
Completed, sir.
Boys, have you done this? Yes or no?
Yes.
Okay, this is all about electric field and electric field lines. Let us try to solve 1 or 2 questions based on this. Simple ones. And these are the questions that you can expect in your examination hall. So I'll just show you the question. Yes, this is the question, and they've asked where is the electric field line more or electric field more. They have given 4 options. Can you tell me which one is the right one, beta?
Sir, option A.
Option A. How did you get option A? Option A is correct. How did you get option A? Guess. Yeah. I can't hear you better. At point A, you can see electric field are very densely packed. Yes or no? They are very dense. They are very close. And therefore, you can say since they are very dense, that means the electric field will be more at point A compared to point B, where you can see electric field lines are well apart. They are well apart. That means electric field will be less compared to the electric field at point A. Everyone understands this? These are the type of
Yes, sir.
questions that you can expect apart from the question based on diagram. This is also a question based on a diagram, but you can see these are the type of question that I have seen in your NEET exam, and I will show you more questions on this. So we will concentrate ourselves on such questions. Let us move on to the next one. In the next one, you have a diagram, and then you have a question. So tell me the answer for this one. You have 2 minutes to do it. It's a very simple question on the concept of electric field lines. Yes, bacha. What is the answer for this one? Tough? Yes, bacha. If Q1 is 12, what is the value of Q2? And the answer is no one knows the answer. The value of Q1, this pink one, is 12. What is the value of this green one, Q2? And the answer is -5 microcoulomb. Why it is -5? Why it is minus? Why it is minus? It is minus because electric field lines are going towards it. You can see the electric field lines going towards it. And therefore, this is minus. Do we understand this?
Yes, sir.
Why it is 5? The number of electric field lines which are coming in or going out tells us about the magnitude of charge. You count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 field lines are going out of the charge Q1, and it is given that it has a charge of 12 microcoulomb. 12 microcoulomb is making 12 lines come out of it. Now, if I count the next one, the green one, 1, 2, 3, 4, 5, there is nothing on the other side. 5 electric field lines are going inside. So, what will be the charge? Q2 equal to, tell me the answer now. The answer would be -5. Do we understand how this has gone above our head saying bye bye, bye bye, bye bye?
Understood, sir.
Next question, sir. The figure shows some of the electric field line corresponding to an electric field. This figure suggests that ding 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 ding. Yes, bacha. What is the answer to this one? Huh? Huh? I can't hear you.
Sir,
1, 2, 3, 4. Which is the answer? A, B, C, D. And the answer is
sir,
C, sir. Electric field at A and C are equal, and it is greater than point B. Do we understand this? Yes or no? No, yes. Huh? Yes or no? No, yes.
Yes, sir.
Pakka na, sir?
Pakka, sir.
Okay. Next one, sir. Which of the following maps cannot represent an electric field? They are not saying which of the following map is the uniform field. They are saying which of the following maps cannot represent an electric field. And the answer is, my dear friends, A, B, C, D. Which one? Huh?
A, sir.
A, sir. Yes, sir. A, sir. A is the right answer, sir. Option number D represents uniform electric field. Option number C represents non-uniform electric field. Option number B also represents non-uniform electric field. But in option D, what you see here, you see lines which are equally placed. And then suddenly you have a line coming which is unequally placed. That cannot happen. So that is why this option is wrong. B, C, and D are correct. Do we understand this? Yes or no? No, yes. We understand this or gone above our head saying bye bye?
Understood, sir.
Now, this is probably not in your course, but this is just if it comes in any case, you should be able to answer this. Charge Q is a positive charge Q. Just by looking at the positive charge, you should be able to tell me what is the answer. A positive charge Q is fixed at a distance d in front of an infinite metal plate. It's a conductor. Metal plate is a conductor. You know the property of a conductor, and you know what happens to a positive charge. Only looking at these two things, conductor and positive charge, conductor and positive charge, conductor and positive charge, you should be able to tell me which of the following diagrams is correct. Conductor, positive charge, conductor, positive charge, conductor, positive charge, and the answer is
Sir, option B.
option B is not the correct option, beta. Because in option B, you see electric field lines going towards the positive charge. How they can go towards the positive charge? How they can go towards the positive charge? They can only go away from a positive charge. So only go away. The only options are options A, C, and D. Option B goes down the drain. Now, the plate is a conductor. Plate is a conductor. Therefore, the lines must go perpendicular. If the line goes perpendicular, this gentleman says, bye-bye, I am not perpendicular. Now, only options that are remaining are A and D. Now, option number D, you can definitely say lines cannot be like this. They cannot just go like this. So, obviously, this is not the answer. And the only thing that fits is A, Abhiram. And that is the answer. Do we understand this or bye-bye?
Yes, sir.
What, sir? You should have been able to give me the answer for this one, sir. Not impressed. This is a question from IIT-JEE of 1996, the year which I appeared in IIT, and obviously I did the question. This one. So that's who I remember. What is the answer for this one? A metal sphere. Metal is a conductor. A metal sphere is placed in a uniform electric field. Which diagram represents the correct path of this electric field lines? The goal thing is a conductor. It's a metal sphere. Which diagram represents the correct electric field lines? And the answer is line number 1, line number 2, line number 3, line number 4. Abhiram thinks it is 4. And the answer is 4. Electric field lines cannot come inside the conductor. So these two boys say bye-bye. Then electric field lines should terminate at 90 degrees and come out at 90 degrees. These are the only two lines which are coming in and coming out at 90 degrees. And therefore, the correct option is option 4. Do we understand this?
Yes, sir.
Only looking at the properties of conductors. Tan, tan, tan. Ask you one more. Let's see who gives me the answer for this one. Where's the question? Let's see. The electric lines of force of the electric field due to two charges Q and capital Q are sketched as shown. State if which is positive, which is negative. One thing is clear. What is positive, which is negative? Huh?
Sir, small q is negative.
Huh? Small q is positive. Electric field lines always go away from a positive charge. So This says bye-bye. This says bye-bye. Only two remain in contention. Capital Q is negative and small q is positive. Which one is correct now? And the answer is option C. More electric field lines are coming out of this gentleman. We just did a question. And less electric field lines are going inside the other gentleman. So the other gentleman should be smaller. The small q gentleman should be larger. Don't go on the way it is written. Small q is written in smaller letter. That does not mean that it is smaller. Do we understand this or just gone about it saying bye-bye? More electric field lines means more electric field. It also means bigger the charge. You understand this? Huh?
Yes, sir.
Yes, sir. No, sir. I am not impressed, sir. You have simple questions on electric field, sir. You should have done this, sir. Okay, sir. Not a problem, sir. Electric field के problem, sir. Okay. There is no electric field का problem here. Okay, then I will try your previous year questions and see what problems have come. Chalo, this one. Let's see who gets me the answer for this one. This is from your 2019 paper, my dear friends. A hollow metal sphere of radius r is uniformly charged. The electric field due to the sphere at a distance r from the center. Which is the correct option? You must remember the formula. I hope you are remembering the formula. You remember the formula. Which is the correct answer, my dear friends? You are getting over with electric fields. You must remember the formula. A hollow metal sphere. Which option is correct, my dear friends? And the correct answer is do we remember the formula? Yes or no? No, yes. Huh? Do we remember the electric field due to a sphere, hollow sphere, conducting sphere? Do we remember it? We don't remember it, sir. Then, sir, how will I get the answer, sir? Very bad, sir. This is what we had done in the last class, sir. I had given you the graph, sir, also, sir. Everything was there, sir. You had written it down also, sir. You had all drawn the graph also, sir. And now you had to use the graph and give me the answer, sir. So now it is in front of you, sir. Now can you tell me which is the right option, sir? Do you remember this? Do we remember this?
Yes, sir.
Then what is the answer, sir? And the answer is, still we don't know. Answer is B. Inside the sphere, inside the shell, conducting shell, electric field is 0. From the center till the circumference, electric field remains 0. On the circumference, outside the sphere, it becomes Q by 4 pi epsilon naught R. After that, it decreases. I had also given you the graph. You have forgotten it. I showed you the graph just now. You could not understand it. Well, then only God will help you. And I will pray every day that God helps you and keeps you safe. This is the answer. 0 from here to here. From 0 to capital R, it is 0. After that, it decreases. The only option which tells us this is option number B, my dear friends. So, my dear friends, B is the correct answer. Can I move forward in life? Do we understand this?
Yes, sir.
What is the faida of writing everything when you can't solve the question, sir? Anyways, I always believe that students are like cash vouchers. Sometimes the cash voucher does not work. We write the wrong code, but you can always get a chance to redeem. You can always try it again. And if the code is written correctly, the cash voucher can still work. So, is it working now? The electric field at a distance 3r by 2 from the center of a charge conducting spherical shell of radius r is E. What is the electric field at a distance r by 2 from the center of the sphere? And the answer is at a distance of 3r by 2, electric field is E. What will be the electric field? At the center of the sphere. At a distance r by 2 from the center of the sphere. And the answer is well, I told you yesterday, I just now gave you a diagram also. Just now I told you also. It seems like your brain is somewhere else. And the answer for this one is 0. Electric field inside the shell is 0. So what I would suggest is you go back home and you draw that table which I had given to you. Do you remember that table? Draw that table 5 times at your home, because if you ever get a question that will be coming from that table, inside the conductor, electric field is 0. Electric field is maximum on the circumference. After that, it decreases. It becomes just like the electric field of a point charge. I told you that many times. Please remember it. Don't forget it. So I'll end up this class here. Take care. Go through this table once again. Write it 2 or 3 times. Put it in front of your study table if you have one. It will help you in get scoring some marks, some very easy marks in the exam. I would dismiss this class now. I'll see you tomorrow. Take care. Have a nice day.